Okay, hi everyone. In this video, we're going to do a little review of Unit 4 on balanced forces. And we're going to just talk about some of the main ideas as you're getting ready for the test. So the most key idea is that force itself is an interaction. So what we mean by that is that in order to have an interaction, you have to have two objects participating. So whether that's a book sitting on a table or the force of gravity acting on me, there's always two objects that are involved. And we talk about the different types of forces, and we classify them, broadly speaking, into two types. We talk about contact and non-contact. Okay, so there's a lot of different examples of contact forces. If we have two surfaces that are pressing against each other, like a book sitting on a table, that's what we call the normal force. Okay, if we have a book that is sliding down a hill or an elephant sitting on a hill trying not to slide, we could have the force of friction. There are forces that exist in chains, ropes, and strings, and we call that the tension force. And we can even have a type of friction that pushes us forwards, and that's what we sometimes call traction. So that's a kind of frictional force. Okay? You can also have non-contact forces, and sometimes these are what we call field forces. So the best example of this is the force of gravity. And contact is not required for a field force, so there's a force between two objects just because of the gravitational field, for example, that exists surrounding the Earth. So we'll talk more about that in just a moment. We can also have different types of fluid forces. You can have the buoyant force. You can have a drag force. These are different types of forces that exist in fluids. Okay. Now what we did in class is we said that every force can be represented by the following structure. You can write the type of force, what the force acts on, and who's doing the force. Okay? So we said that this was, for example, the force of gravity on me by the Earth. And if I was going to draw a picture of that, here's a force diagram of the force of gravity acting on a person done by the Earth. So it's the type of force, it's the feeler, and it's the dealer. And that's kind of what we had talked about. Okay, so now let's get into Newton's laws. Just wipe this off real quick. Okay, so we're going to be talking about two of Newton's laws right now, and in the next unit we'll talk about the last one. Okay? The first of Newton's laws says that objects like to maintain their current state of motion. Okay? And that's what we sometimes call the law of inertia. And that got a little bit messy. Let me just redraw that. Okay? So Newton's first law, also known as the law of inertia, okay, is that objects maintain their current state of motion unless acted on by an unbalanced force. Okay, now in this unit we're talking about balanced forces. So when we're talking about Newton's first law, there's really two ways that an object can maintain its state of motion. And so when we are thinking about having balanced forces, there's two conditions for that. So if forces are balanced, essentially that means that the acceleration is 0. And that can take two forms. One is that the velocity is 0, or the other is that the velocity is constant. Okay? This one right here is the one that really gives people a lot of trouble. The idea that something can be moving and yet have forces acting on it. So we saw a lot of examples of this in the packet where it said that an object is moving with constant velocity, but yet the forces are balanced out. Okay. And we also talked about the force of gravity, and we had the spring lab, and we came up with the conclusion that the force of gravity is equal to the mass of an object times the gravitational field strength. Okay? So this little g right here, we called the gravitational field strength. And we said that that had the value of about 10, or 9.8, newtons per kilogram, which says that when an object is in a gravitational field, the field force between that mass and the field is basically 10 times the mass, okay? So the mass is measured in kilograms, but the force is measured in newtons, okay? And of course, G is newtons per kilogram, so that kilogram would cancel out. Okay, the last thing I want to review with you is how we can split up forces if we have forces at an angle in order to analyze a situation, such as an object on a hill or going down a ramp. Okay, so just going to get rid of a little bit here. And the important thing is that we want to split all of our forces to go with our set of axes. Okay. And so, for example, if I have a hill and I have my object sitting on a hill, then I would represent that as a dot if I was going to draw forces on it, right? So I'll just take that and put a little dot. And then we would have forces, okay? We would have the force of gravity going straight down. We might have a normal force going perpendicular. And I'm not putting all the little sub letters there, but that's okay. And then if it's sitting there, we might have a force of friction pointing up the incline to keep it from sliding down. Okay, so the biggest challenge in this is recognizing that we don't want to use our normal x and y axes, because then we would have to split two forces into components, and we don't want to do that. Instead, so don't do that. Instead, what we do is we come up with a new set of axes called perpendicular and parallel. And then what we can do is take the force of gravity and split that up into a component that is perpendicular to the ramp. We can call that FG perpendicular. And we can have another component down here, which we call FG parallel, which is parallel to the ramp. Okay, so finally, if I have an angle here, which is theta, that will be the same as this angle right here. Now the reason for that is that I have a right angle between the bottom, the horizontal, and gravity. And so this angle in here is actually 90 minus theta to make that a right triangle. And then I have another right angle right here. So I have 90 minus theta plus theta gives me 90 again. So that means that I can find this as FG cosine theta, and this would be FG sine theta. Okay, so those are kind of the basics. Remember, when you're studying, you want to think carefully about your force components. And remember that if forces are balanced, that can mean that the speed is 0 or that the speed is constant.